Here's part 3. Here's a possibility. I mean, I was just a few minutes thinking about it. At first, feeling like it's impossible, but it is possible. I wouldn't call this the following local realism at all, but it could be one way to address the issue about especially the double slit arrangement and the results. What do you call it? The unanimous results of that. Look, they use particles and they use photons, essentially, for that experiment. And it always comes up the same, displaying interference and or the opposite of interference, which is like reinforcement, right? So it's one or the other. It's an interference pattern or a reinforcement pattern, like two waves coinciding, reinforcing each other. So it's one or the other, depending on the particles, energies used, and the double slit arrangement, based on, typically what wavelength of the particle and or photon. Now look, every type of particle that they use, whether it's actual real particle or wavicle like electron or proton, those actual particles, or in the old days might have been called wavicles from a de Broglie standpoint, they exhibit what we call group characteristics. So like with Bose-Einstein condensates, those are group characteristics that show that matter can behave like photons do in group fashion. So it's quite possible that every single type of particle used, whether it's a photon or otherwise, has group characteristics. And those group characteristics, in a sense, are encoded in the particle itself, even a single particle. So it's, like I said, this is kind of conjecture, and it's not necessarily explaining things from a local realistic viewpoint when you start thinking about group characteristics. So it's like it's an augmented local realistic perspective that also includes group characteristics when you speak of individual particles. And this is a real loose usage of terminology. But think of each particle, whether it's a photon or electron or proton, as a basis for a subspace, and that subspace would be a set or group of those things, those particles. So a single photon would be, the mathematical analogy here, loosely used, and these wording very loosely used, a basis for group subspace, and those characteristics would undeniably be exhibited at the detector side, if we consider those. So again, I would not call this local realism, because we're talking about group characteristics of particles, whether it's Bose-Einstein condensates or photon group characteristics like that exhibited in lasers or wave packets. So when we start talking about wave packets, we're actually talking about typically one or the other actual real wave packets, like envelopes. So imagine like a large sinusoidal, but three-dimensional, a large sinusoidal envelope, or packet, wave packet. That's one example of what we call a group characteristics. It's a wave packet, whether it's particles or particles of light, photons. and those group characteristics would translate, what do you call it, simultaneously and be easily explainable by physicists to produce the interference or whatever patterns that we get at the detector level or stage of the experiment. The thing is, we have to assume that even single particles carry with them potential group characteristics theoretically, and perhaps in that way can explain interference patterns produced by single particles passing through a double slit arrangement. But that's a more theoretical approach that could explain double slit. Not necessarily from a local realistic standpoint, from modeling group characteristics of wave packets and using that information to explain interference patterns at the detector side or detector stage of the experiment. Anyways, so it's encouraging from my point of view that they are sort of reconcilable if we consider group characteristics. I'm not saying GR is reconcilable with the standard model, but that's not what I'm saying at all. What I am saying is that there is hope to understand what we call non-locality or label non-locality. Perhaps that's also a group characteristic manifestation that we're possibly misinterpreting to mean non-locality, but perhaps yet again, it's a group characteristic that we're misinterpreting. When physicists start thinking about group characteristics like so-called superluminal activity, like phase changes or phase changes in the envelope conceivably can be so-called superluminal, but that doesn't mean messages or information can be translated superluminally by using group characteristics to encode information, for instance. It's like the idea, another analogy would be taking white noise and using that to transfer data. That's another analogy that's perhaps quite valid. And in other words, white noise generated, or sampled, and it is truly white noise and not artificially generated, truly white noise, and then somehow using that to communicate. I thought of that idea many, many years ago, but it's, it's not that it violates causality, it's just that you're trying to ascribe meaning to something that has no meaning, and then use that to communicate. So in other words, like I said, superluminal aspects of group behavior cannot be used to communicate FTL, faster than light, and violate causality in that way. There's just no way around that particular idea. There's nothing in the universe that we can tweak. There's no method, no mode of communication, no FTL, no quantum qubit information or communication scheme that's going to violate causality. At the same time, it cannot do FTL communications. And people have admitted that, scientists have admitted that, while at the same time pursuing other aspects of quantum communications and whatnot, quantum computing. Anyways, this is Sam signing off for part 3.